Assalamualaikum and good day. My name is Nazmi bin Mizan. Would like to present my final project entitled Torrefaction of Empty Fruit Bunch by introducing superheated steam. Throughout this study, these are the important keywords. The first one is torrefaction, the main process. The biomass used in this project is empty fruit bunch and additional of superheated steam. Now we jump a little bit into introduction. In Malaysia, large amount of EFB generated by palm oil mill and it is vastly available. So this is promising towards renewable energy, but EFB have some drawbacks that contribute to less efficient use of EFB, especially lower in heating value and high moisture content. To overcome this problem, process called torrefaction for treatment of biomass in low temperature range of 200 degrees C to 300 degrees C can be applied, and it is based on removal of oxygen from biomass. In addition to torrefaction process, superheated steam was introduced in the process where, based on research, it can help to improve quality of fuel produced. Literature review had been made throughout the study, so these are some of it. For EFB, it has a non-uniform shape and contains high moisture content. And in palm oil mill, solid waste were usually used as combustion fuel in boiler system to supply thermal and electrical energy, but they only select those which are easy to burn and do not require further treatment. This led to failure to use EFB due to its disadvantages. Figure 1 shows the data from recent study on torrefaction process on EFB, where calorific value and carbon content increase with increasing temperature. Why superheated steam? It is being discussed as pre-treatment process for the production of solid biofuel to increase the calorific value of the biomass. And a recent study suggests that superheated steam of wood results in material with favorable fuel properties and good pelletizing properties. It also can heat materials without oxidation because it does not contain oxygen and carbon dioxide. Drying speed is much faster and can be operated at 1 atmospheric pressure. Next are the problems regarding the EFB. First, the disposal problem due to large amount of EFB being generated. Second, wasting renewable energy sources because usually the waste are being incinerated. Lastly, the lower in heating value and also high moisture content. Objective of this research are to improve the drawbacks of EFB, which is lower in heating value, to analyze the torrefied EFB with original EFB, to compare the heating value of torrefied EFB with cold data from other researchers, and to observe the effectiveness of introducing superheated steam by comparing calorific value from other researchers. This project was carried out using rotary kiln carbonization furnace as shown in the picture. It consists of evaporator, act as steam generator including water feed pump, the body furnace where reactor inside, and last one is condenser system. Overall methodology throughout this project as summarized, starting from preparation of the sample itself, rotary kiln carbonizer setup, torrefaction of EFB, the process, and the last one is the product analysis. Now we proceed with result of analysis of this project, which consists of ultimate analysis, calorific value, when prevalent diagram, mass yield, and effectiveness of superheated steam. Ultimate analysis, which is the elemental analysis to obtain the percentage of carbon, hydrogen, nitrogen, sulfur, and also oxygen in raw EFB and also torrefied EFB using CHNS analyzer. Based on the result, only carbon, hydrogen, and oxygen that have been highlighted because they are the main element to be observed in this project. So results show the percentage of carbon increase with increasing temperature, Increase in C to C concentration lead to increase of heating value. Hydrogen and oxygen decrease due to loss of water and carbon dioxide. For nitrogen and sulfur, most biomass fuels have sulfur content below 0.2%, and the result obtained also below 0.2%. So as expected, sulfur content can be negligible because its combustion does not contribute significantly to the sulfur emission in the combustion. For nitrogen, the content in biomass varies from 0.2% to more than 1%, and it is responsible for only nitrogen oxide emission during combustion. Previous results state that increase in C2C concentration lead to increase in heating value. So this graph proves that increase in torrefaction temperature will increase the carbon content and also the heating value. The graph shows the highest calorific value obtained is 23.6 megajoule per kg at 300 degrees C. Emira 2011 also reported the same trend. This is an improvement of torrefied EFB where the calorific value increased about 50% higher than the raw EFB, and the calorific value obtained in this project was calculated using formula from the MIBAS 1997, and the HHV resulted from all the correlation in the journal show mean differences from the measured values range from 0.1% to 4%. From that journal, it's conclude that it's a good agreement to use the formula. This is one equivalent diagram that show the hydrogen carbon and oxygen carbon ratio of raw EFB, torrefied EFB, and bituminous coal from Taim 2016. Based on the diagram, when torrefaction temperature increase, OC and HC ratio are closer to coal. This might due to drying and devolatilization process occur during process from removal of surface water and also carbon dioxide. So torrefied FB has potential to use as a good solid fuel. Observation of the mass yield in this project also had been done. As we can see, the bar graph, the mass yield decreased with increasing temperature due to degradation of lignocellulosic compound in the biomass, especially hemicellulose that decompose, loss of moisture, and thermal decomposition that form volatile and gaseous product. Last but not least, to see the effectiveness of superheated steam in torrefaction process. In the figure, there are three different conditions, which are superheated steam, normal combustion, and nitrogen purging. Torrefaction with nitrogen purging from Sulaiman 2016 obtained calorific value of 21.93 megajoule per kg at torrefaction temperature of 300 degrees C with 90 minutes residence time. Purpose of nitrogen purging only for removal of oxygen and also stable climate process during the experiment. In comparison to this study, by introducing superheated steam in the system, the highest calorific value obtained was 23.5 megajoule per kg. So it can be proven that the presence of superheated steam can help to improve the heating value of EFB even more with shorter process time. For mangrove wood coal data, the hard type biomass from Kuala Sepetang coal factory took about 1 month to obtain calorific value of 24.05 megajoule per kg. Not to compare, but from the result obtained throughout this project, in the future, the hard type biomass can be treated using this method to be upgraded even more instead of using normal combustion with longer process time. To be concluded, higher heating value can be increased using this torrefaction process as it is one of the problem from FB to be used efficiently as a solid fuel. Torrefied FB has potential to use as a good solid fuel due to lower in oxygen to carbon ratio. By introduce the superheated steam, it make the FB easy to be upgraded due to its ability to open up the fiber. So this is the references throughout this study, and that's all from me. Thank you.